All right. Now, this question now, it says, the diagram below shows a hexagonal prism. A hexagonal prism, and a hexagonal prism is a prism with 6 faces. That's all they're saying. Well, not 6 faces, but it has 6 sides. The prism around it has 6 sides. All right. So that's a hexagonal prism. It has 6 sides. So remember, if you're to look at something with 4 sides, this is a quadrilateral. Something with 5 sides, septagon. I'm just drawing a diagram with 5 sides. This is a septagon. All right. And then something with 6 sides now is a hectagon. All right. So it just means that it's a prism with 6 sides. All right. So this is 1, 2, 3. Wait, 1, 2, 3, 4, 5, 6. Maybe something like this. This is 6 sides. Or typically you'll see something like this. All right. These are hexagons. 1, 2, 3. These are hexagons, all right? Something with 6 sides. 1 side, 2 side, 3 side, 4 side, 5 side, 6 side. This as well. 1 side, 2 side, 3 side, 4 side, 5 side, 6 side. These are all hexagons. So what they're saying is that the base have 6 sides. 1, 2, 3, 4, 5, 6. That's all they're saying. It's a hexagonal prism. So now let's read the question. So hex means 6. Now a prism has, this prism has how much faces? So let's add up how much face it have. How much face it have? Well, face is just the flat surface that we can count. So it have 1 face here. It have 2 face here. There's another face right here. So, all right, 1 face, 2 face. This is for the back. All right. Then let's use burgundy for these now going around. Now going around it, it's going to have 6 faces. Can we see that? It's going to have 6 faces going around. 3, 4, 5, 6, 7, 8. So it have 8 faces in total. This would be 4. This side will be 5. This side will be 6. This side will be 7. And down by the bottom will be 8. So it has 8 faces. How do I know that? It has 6 faces going around because it's a hexagon, and then 1 and 2 face. All right, 1 at the front here and 1 at the back here. All right, so the hexagon, it has 8 faces. Cool, cool. It have 8 faces. Now, next thing it wants are vertices and edges. I like to start with the vertices. The vertices are just basically where they're just the corners. All right, so I'm drawing blue dots to show you the corners. 1, 2, 3, 4, 5, and 6. These are vertices I'm putting. Then there's 1, 2, 3, 4, 5, and 6. So in total, what we have is 6 plus 6 is 12. All right, so in blue, there are 12 vertices. So again, what are vertices? Are just the corner them. In Caribbean Creole term, it's just the corners them. All right, some persons might get fancy and tell you a fancy definition that vertices, these are where the edges meet or where the edges are cornered. All right, but I'm not going to get into that fancy definition. Cool. Now, the next one we need is edges. Now, edges, this is where 2 faces meet. Whenever 2 faces meet, give you an edge. So what am I saying is an edge? So this is an edge. Going down here, this is an edge. So that's 1. Where two faces meet is an edge. This is another edge, that's 2. This is another edge, this is 3. This is another edge, this is 4. This is another edge, this is 5. This is another edge, 6. This is another edge, 7. This is another edge, 8. This is another edge, 9. This is another edge, 10. This is another edge, 11. This is another edge, 12. This is another edge, 13. This is another one, 14. This is another one, 15. This is another one, 16 edges. Let's see if I left out any. 16 edges. 1, 2, 3, 4, 5, 6. All the edges around this are oh, here. This is another one, 17. And then finally this right here, 18. So there are 18 edges. All right. So in terms of a definition that I can give you, edges is where a face meet, where two faces meet. All right. So if this ain't so clear, I'll just leave a simple diagram. I'll put on a diagram to show. Just a diagram, like let's say they give you something like this, right? Just so we understand edges clearly. Edges is where two faces meet. I know my diagram is not looking good. All right, we know faces. Faces are the flat surfaces we can count. Think of this as a box. It has, we count all the faces, 1, 2, 3, 4, blah, blah, blah. Now when this face meet this face, this line right here is an edge. All right, when this face 1 and this face 2 meets this, when they meet each other, this intersection is known as an edge. When this face 1 meets this face 3, this line right here is known as an edge. This is known as an edge. This is known as an edge. So I hope that clarifies what is edge, and you'll know how to find out what is edge. Now, what are vertices? Vertices are just the corner of them. So just point them at the corner. So this is a vertex. This is a vertex. This is another vertex. This is another vertex. This is another vertex, and so forth. All right. Nothing major. All right. So we had that there were 18 edges, 12 vertices, 8 faces. Easy question, that too easy, soft, with a capital T. Going on to question 4. Question 4 says, a sports club owns a field, P, Q, R, and S in the shape of a quadrilateral. A scale diagram of this field, is in the shape of a quadrilateral. All right, 1 centimeter represents 10 meters. The field is not divided. The field is to be divided with a fence from P to the side RS so that the different sports can be played at a different time. So they're going to cut the field so you can play some different sports. So the field is to be divided with a fence from P, so this is a from position, from P to the side RS. All right, so we can divide it for them. Let's go ahead and divide it. So what they're saying is they're going to cut the fence from P over to RS. So they're going to cut it in 2 so they can play 2 different sports. All right. So let's say that is where they cut it now. All right. So this is the fence. This is now the fence. All right. That's the fence. So using a straight edge and a compass, construct the line representing the fence. So this is the fence, but of course I don't have a compass to make it straight. So you know, you swing your arc and you slash it here, then you draw your straight line. All right, this is the fence. All right. Then it says write down the length of this fence. So all you're going to do is measure this fence right here. Of course, you're gonna have to put it on you're gonna use your ruler and measure this fence. All right. You're gonna use the ruler and measure this fence. Of course, I don't have the physical paper to measure it. And so what I'm gonna do is, let me see. Just putting my ruler that I have on the computer screen, I am getting that this is a length of 4.5. I'm getting 4.5 centimeters from my ruler, but you should measure it, all right? I'm getting 4.5 centimeters, but then 1 centimeter represents 10 meters. So what this actually works out to be is 45 meters. The fence for me is 45. I don't want to write the answer here because I don't actually have this physical paper to do it. All right. All right. So from me putting a ruler on the screen, all right, from me putting a ruler on the screen, I'm getting 4.5 centimeter. All right. Only thing I can say is not accurate. All right. I'm getting 4.5 centimeter. That is, I am actually getting that this is, I think it said 1 centimeter is 10 meters. So that is, I'm getting 45 meter. So I'm getting 45 meter, but mine is not accurate. Again, it's not accurate because I don't have the physical paper. So just to make that clear, it is not accurate since it's not the actual paper I'm measuring. But you're in the exam, you're gonna have the actual paper. This is a soft copy. All right, so this is not entirely accurate. Now let's go to part C. Part C is where it gets really nice. All right. Part C, it says a quadrilateral PQRS and its image P prime, Q prime, R prime, S prime are shown on the grid below. It says write down the mathematical name of the quadrilateral PQRS. Now this is a trapezium. No question about that. This is a trapezium. All right, that's the name of this shape. So we have to remember what are the different types of quadrilateral. You need to remember what's a kite, what's a rhombus, what's a rectangle, what is a square. You need to know all of that stuff, all of that good stuff. All right, and so this is a trapezium. So no issues there. We're just having fun. We're having fun. So after we tell them that that's a trapezium, it says PQR is mapped onto PQRS by an enlargement with a scale factor of K about a center CA. Using the diagram above, determine A, B, and K. Okay, so let's find the scale factor first. I like to find the scale factor first. To find the scale factor, look at this. To find the scale factor, you can find the length of one side of the image divided by the length of that same side of the object. And that will give you the scale factor. All right, that's going to give you the scale factor. So look at it. You have Q prime, P prime, Q prime, P prime. When you divide that by Q, P, what you're going to get is the length of Q prime, P prime. That looks like 1, 2, 3 units. And that's divided by 1 unit. And so the scale factor is 3. The scale factor is 3. All right, so K is equal to 3. This is how you find the scale factor. Now you could go ahead and use a different approach where I'm going to do this in blue. You could find the length of the object PS and divide it. You divide the image rather by the length of the object. So the image, which would be P prime, S prime, P prime, S prime. When you divide that by the length of PS, that's going to give you P prime, S prime is 1, 2, 3, 4, 5, 6 units, and 6 units being divided by the length of PS, which is 2 units, 6 over 2, which is 3. 6 over 2, which is 3. All right, and so that's the scale factor. The scale factor K is equal to 3. So K equal 3. So anyway you take it, the scale factor at 3. Nice and easy. So the scale factor is 3. So we did the first part. Now the next part to do is find the center of enlargement. To find the center of enlargement, what we do is we draw a straight line. Like for example, a straight line that passes through R and R prime. They're going to connect. We're going to draw a straight line through R and R prime, a straight line through Q and Q prime, and a straight line through, all of them going to intersect at one point, all right? So a straight line through R and R prime, from R and R prime, this line is not accurate. I want to get it accurate. Let me get this line accurate so you can actually see the correct center of enlargement. So we're going to get it accurate. It passes through R prime, which is right here, R prime and R. All right, that's a black line to represent it going through R and R prime. Then you do the same for Q and Q prime. You draw a straight line passing through Q and Q prime. I think I found the center of enlargement already. Just to continue. Then you draw a straight line through P prime and P. Wherever they intersect, that's the center of enlargement. So because my lines are not so straight, then clearly we're not going to get the accurate thingy, but this is the center of enlargement. Where the three lines intersect, that's the center of enlargement. And the center of enlargement is, this look like x is -4 and y is 1. The center of enlargement is -4, 1. Now that we find the center of enlargement, we can actually find our values of A, B, and B. We can find our values for A and B. The center of enlargement is AB, so we can conclude that A is -4 according to our diagram, and B is equal to 1. B is equal to 1. So again, primarily what I really want us to remember is that, look at this, the center of enlargement. To find the center of enlargement, we draw a line that passes through the object and the image. So we'll draw a line that passes through the object Q and the image Q prime. We draw a line that passes through the object R and R prime. We draw a line that passes through the object P and P prime. They will connect wherever these three lines meet. It meets at the center of enlargement. All right? That's how we do this question. Nice and easy. Soft. This question is soft. And that takes care of question 3.